Hello, all. Welcome to the Counting Well exam prep live session. We know exams are round the corner. The two greatest factors of all successful exam results are revision and practice. Remember that practice doesn't make you perfect but helps you to perform better. Planning beforehand allows plenty of time for your revision. And so, we are here to shoo away your exam fear and help you revise your concepts before it's too late. So stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through the chapter Playing with Numbers from Class 6. Let us see factors and multiples. So what are factors? A factor of any number is an exact divisor of that number. For example, if you take factors of 63, you will get 1, 3, 7, 9, 21 and 63 as factors because 1, 3, 7, 9, 21 and 63 exactly divides 63. Let us see one more example to find the common factors of 12 and 36. Here we have given two numbers 12 and 36. Let us see the factors of 12. They are 1, 2, 3, 4, 6 and 12. Factors of 16 are 1, 2, 4, 8 and 16. Let us see what are the common factors for these two numbers. We can see 1 is common among the factors of 12 and 16. Also, 2 is common among the factors of 12 and 16. And then we have 4 as common factor for 12 and 16. That's why we have here 3 common factors for 12 and 36. In this way, we have 1, 2 and 4 as common factors of 12 and 36. Next, let us see the multiples. A multiple of a number is a product of that number and another number. For example, multiples of 7 are, we are taking multiplication of 7 with another number. So we will start with 1. So 7 ones are, we have 7. 7 twos are, we have 14. 7 threes are 21. 7 fours are 28. 7 fives are 35. Now let us see how to find the common multiples of two numbers. Common multiples of 2 and 3. We have multiples of 2 as 2, 4, 6, 8, 10, 12 and so on. Multiples of 3 are 3, 6, 9, 12, 15 and so on. Now let us see the common multiples. We can see 6 is common among the multiples of 2 and 3. So we have 6 as a common multiple. Then we have 12 as a common multiple. In this way we have common multiples. In this way we have common multiples as 6, 12 and so on. The list is non-ending. Let us see the types of numbers. Let us see what is a perfect number. If sum of all factors of a number is equal to twice the number, then we say that the number is perfect. For example, 6. We see that sum of factors of 6 is 1 plus 2 plus 3 plus 6. Note that 1, 2, 3 and 6 are the factors of 6. We get this sum as 12. Next, let us twice this number. We have twice of 6 as 12. So this is called perfect number. Let us see what is a composite number. A composite number is a number having more than two factors. For example, 4, 6, 8. Note that 4 has more than two factors, that is 1, 2, and 4. Similarly for 6 and similarly for 8. Let us see what is a prime number. A prime number has only two factors, that is 1 and the number itself. So we have prime numbers as 2, 3, 5. We have many prime numbers. Here we have three examples, 2, 3, and 5. Now let us see what are twin primes. Prime numbers whose difference is 2 are called twin primes. For example, here we have 5 and 7. Note that the difference between 5 and 7 is 2. That's why the pair 5 and 7 are called twin primes. Now let us see types of numbers. First we will see even number. The digit at the ones place is 0, 2, 4, 6 or 8. For example, we have 32. The digit at the ones place is 2. For the number 14, the digit at the ones place is 4. For the number 18, the digit at the ones place is 8. So 32, 14, 18 and so on are the examples of even numbers. Let us see what is an odd number. If the number has the digit at the ones place as 1, 3, 5, 7 or 9, we have odd number. For example, 21. The digit at the ones place is 1. For 43, the digit at the ones place is 3. 5. It is a one-digit number. So this is odd number. Let us see what are co-primes. Two numbers having only one as a common factor are called co-primes. For example, 6 and 35. Let us see the divisibility rules. Rules for checking the divisibility of the given numbers by 2, 3, 4, 5, 6, 8, 10, and 11. Let us quickly revise these rules. Let us see the divisibility rule for 2. If the number has any of the digits as 0, 2, 4, 6, or 8 in its units place, we say that number is divisible by 2. For number 3, if the sum of the digits of a number is divisible by 3, we say that the number is divisible by 3. If the number formed by its last two digits is divisible by 4, we say that number is divisible by 4. If the digit at the ones place is 0 or 5, then we say that number is divisible by 5. If a number is divisible by both 2 and 3, then we say that number is divisible by 6. That means the number should be divisible by both 2 and 3 also. If the number is only divisible by 2 but not by 3 or vice versa, then we cannot say that the number is divisible by 6. Next, we have divisibility rule for number 8. If the number is divisible, or if the number formed by the last three digits is divisible by 8, we say that the number is divisible by 8. So you have to check the last three digits, note down the last three digits and check if it is divisible by 8. In such case, we say the number is divisible by 8. Next, if the sum of the digits of a number is divisible by 9, we say that the number is divisible by 9. So here you have to check the sum of the digits of a number. Next, if the digit at the ones place is 0, then the number is divisible by 10. So you have to check the digit at the ones place. Now, if the difference of sum of the digits at even places and odd places is 0 or divisible by 11, then we say the number is divisible by 11. Next, we will see prime factorization, that is, representation of a number as a product of its prime factors. So let us factorize number 550 by division method. So here we can see 2 is a factor of 520. 2 is the least number. We can divide 520. So we have 2 into 260, 520. 2 into 130 is 260. 2 into 65 is 130. 5 into 13 is 65. And 13 ones are, we have 13. Now we will write down these numbers as a product. So 520 is equal to 2 into 2 into 2 into 5 into 13. So in this way we have formed the prime factorization of 520. Next, let us see prime factorization by factor 3 method. Let us find the factors of 112. We see the smallest number which divides 112 is 2. So we have 2 into 56 as 112. Now we factorize 56 as 2 into 28. Then we factorize 28 as 2 into 14. And then we have 2 into 7 as 14. Now we will write down these numbers as product. So 112 is nothing but 2 into 2 into 2 into 2 into 7. So we have 4 times 2 multiplied by 7. So in this way, we have found the prime factorization of 112 by factor 3 method. Now let us see what is HCF and LCM. HCF of two or more numbers is nothing but highest or greatest of their common factors. So highest or greatest of their common factors, this is the abbreviation for HCF. So HCF stands for highest common factors. What is LCM? LCM is the lowest of their common multiples. Now let us find the HCF and LCM. Let us see how to find HCF of two numbers 36 and 84. Let us factorize 36. We can see 36 can be factorized as 2 into 2 into 3 into 3. For this factorization, we can use either factor 3 method or division method. So 36 can be written as 2 into 2 into 3 into 3, and 84 can be written as 2 into 2 into 3 into 7. Note that these numbers are prime numbers. So these are the prime factors of 36 and 84. Now for HCF, we'll see the common factor as 2. Then we have again 2 as a common factor. Then 3 as a common factor, and we take the product of these factors. In this way, HCF of 36 and 84 is 12. Now let us find LCM of 12 and 18. We see that LCM of 12 and 18 is 36. Let us see how to find LCM. We see that 12 can be factorized as 2 into 2 into 3, and 18 can be factorized as 2 into 3 into 3. We see that 3 and 2 are the prime factors. So this factorization is called prime factorization. Now LCM is equal to, here 2 is common, so we'll copy this 2. Next we have 3 as common factor, so we'll copy this, and then we will write the uncommon factors, that is 2 and 3. So we get 36. Now by division method we can find LCM. Note that we can divide 12 and 18 by 2. So we have 2 into 6 equals to 12, 2 into 9 equals to 18. Next, again we will divide 6 by 2. So we'll get here 3. Since 9 is not exactly divided by 2, or 2 is not the exact divisor of 9, we will copy 9 as it is. Next, we have here 3 and 9. Since we have here 3 and 9, we'll divide these numbers by 3. So we'll get 3 ones are 3 and 3 threes are 9. Next, we will take number 3. Since 3 cannot divide 1 exactly, so we have 3 times 1 equals to 1, or we have to copy 1 as it is. Then we have 3 times 1 equals to 3. So the product of 2 into 2 into 3 into 3 will get LCM as 36. Let us see the relation between HCF and LCM of numbers. We see that HCF into LCM of two numbers equals to product of two numbers. Okay, we have received one doubt, so we will repeat the HCF and LCM one more time. Let us see what is HCF and LCM of numbers. HCF stands for highest common factors and LCM stands for lowest common multiples. Let us see the methods to find the HCF and LCM of numbers. Once you understand what is HCF and LCM, then we can find the HCF and LCM of two numbers by prime factorization. Now, we can prime factorize the number 36 and 84 either by factor tree method or by division method. So for 36, if we use the division method, you can prime factorize it as 2 ones are 2 eights are. That means 2 into 18 is 36. Then we have 2 nines are 18. Then we have 3 times 3 as 9. Then we have 3 times 1 as 3. So writing these numbers as a product, we get the prime factorization of 36. Similarly, we factorize 84 and we will get 2 times 3 times 7. Now, we will check the common factors. Because HCF stands for highest common factors, we first need to find the common factors among them. So we will take 2 as common and write it as 2. Then we have again 2 common. Then we have again 3 common. We'll copy these numbers and take their product. We will ignore 3 and 7. And in this way, we have 2 into 2 into 3 as 12. So HCF will be equal to 12. Now let us find the LCM of 12 and 18. First of all, we prime factorize 12 and 18. Similar way, we can use division method or factor 3 method. So prime factorization of 12 is 2 into 2 into 3 and prime factorization of 18 is 2 into 3 into 3. While taking LCM, we will copy 2 once because it is common. Since we are finding the lowest of their common multiples, so first we will check the common factor. Then the next common factor is 3. We'll copy this. And then we have the uncommon factors. We need to write uncommon factors in the product as well. So taking the product of 2 into 2 into 3 into 3, we get 36. To find LCM using division method, we follow this procedure. We find a number which divides 12 and 18. So we take the number as 2. 2 exactly divides 12 and 18. So we have 2 6 are 12 and 2 9s are 18. Then we find a number which exactly divides 6 and 9. In this case, we have 2. Because there is no common number which divides both 6 and 9. So we will find a number which divides 6. You can also take 3 here. But since 2 is less than 3, we'll take 2 first. So we have 2 3s are 6. And since we cannot divide 9 exactly by 2, as we cannot get a integer, that's why we copy 9 as it is. Now we find a number which exactly divides 3 and 9. So we have number 3. 3 1s are 3 and 3 3s are 9. We will continue this procedure till we get 1 and 1 in the last step. So again, we want to find a number. Since we have here 1 already, we will find a number which exactly divides 3, and that number is 3. That's why we have 3 into 1 as 3. Now we take the product of these numbers, which is nothing but the LCM of numbers. I hope now this is clear. Now let us move to our next topic, which is relation between HCF and LCM of two numbers. HCF into LCM of two numbers is nothing but the product of two numbers. So LCM of two numbers is nothing but product of two numbers divided by HCF of two number. HCF of two numbers is nothing but product of two numbers divided by LCM of two numbers. For example, the HCF and LCM of two numbers are 50 and 300 respectively. If one of the numbers is 150, find the other one. In this question, the HCF and LCM of two numbers are given, which is 50 and 300. Now, one of the number is given as 150. We are going to find the other number. So we can find other number as HCF into LCM divided by one number. We get this formula or we get this result using our first equation. So we have 50 into 300 divided by 150, which is equal to 100. Now let us see some tricks for the exam. Co-prime numbers. Co-prime numbers need not be prime numbers. For example, 4, 9 are not prime numbers, but they are co-prime as they have only 1 as a common factor. So, it is not necessary that the set of numbers should be prime numbers for that set to be co-prime. Here we can see 4 and 9. Neither 4 nor 9 is a prime number, but they are co-primes because they have only 1 as a common factor. You can see that the factors of 4 are 1, 2 and 4. Factors of 9 are 1, 3 and 9. You can see there is no other common factor other than 1. That's why we see 4 and 9 are common factors. Next, we will see divisibility rules. The best trick for this exam while solving the problems based on divisibility rules is to understand and learn the table of divisibility rules. So a number is divisible by 2 if the condition given is satisfied. Similarly, for other numbers like 3, 4, 5, 6, 8, 9, 10 and 11. Now let us see one trick to find LCM of two numbers. For example, consider 18 and 22. The first step is to find the HCF of 18 and 12. See that the prime factorization of 18 is 2 into 3 into 3. Prime factorization of 22 is 2 into 11. So while finding HCF, we check the common factor. And then we take their product. Since here only 2 is common, that's why we have highest common factor as 2. In the next step, we divide the HCF by either number. So let us choose one of the numbers. Here we have choose 18. So we divide 18 by 2 because 2 is the HCF. So 18 divided by 2 is 9. Now for the step 3, we take that answer and multiply it by other number. So here other number is 22. We take the number obtained in the step 2 and multiply it by other number which is 22. So we get 198. This is the LCM of 18 and 22. So the LCM of 18 and 22 is 198. Now you have to remember the HCF of two co-prime numbers is 1. As seen previously, 9 and 4 are co-prime. So the highest common factor in that case is 1. So here we have example. The HCF of two co-prime numbers 6 and 35 is 1. Now, the LCM of two prime numbers is their product. For example, let us take prime numbers 5 and 7. If you find the multiples of 5 and 7, you will find that the only common multiple is 35. That is 5 into 7. So whenever you have given 5 and 7, then the LCM of two prime numbers is 35. Also, among two numbers, if one is a multiple of the other, the LCM will be the higher multiple. For example, the LCM of 12 and 36 is 36. You see that 12 is a multiple of 36. We see that the multiples of 12 are 12, 24, 36. So if we take the multiples of 12, we have 12, 24, 36 and so on. We see that 36 is one of the multiples of 12. That's why the LCM will be the higher multiple, which is 36. Now let us see what are the some common mistakes that students do. First common mistake is children omitting one and the given number in the list of factors. Now, what are the factors of 6? Are they only 2 and 3? No. 1 and the number itself are also the factors of the given number. So the factors of 6 are not 2 and 3 alone. Hence, the factors of 6 are 1, 2, 3 and 6. Now, children often get confused between odd and prime numbers. Let us check which of the following are prime numbers among the list of numbers given here. The numbers given here are 2, 3, 4, 5, 7, 9, 13 and 16. We know that prime numbers are numbers whose only factor is 1 and itself. The prime numbers among the list of numbers given here are 2, 3, 5, 7 and 13. Many times, the terms prime and odd numbers may cause confusion. Note that the only even prime number is 2 and all other prime numbers are odd. So we can say that every prime number is odd except 2. That does not mean that all odd numbers are prime numbers. For example, 9. 9 is not a prime number since it has It has more than 2 factors, 1, 3 and 9. For better understanding, let us categorize the numbers as follows. Here we can see numbers can be odd, even, prime or composite. 2 is the only even prime number. The numbers which can be prime and odd are 3, 5, 7, 11, 13, 17, 19, 23 and so on. The numbers which are odd composite, the examples are 9, 15, 21 and so on. The numbers which are composite and even are 4, 6, 8, 10, 12, 16, 18, 20, etc. So note that all prime numbers are odd except 2, but all odd numbers need not be prime numbers. Let us see the difference between prime factor and factor. We have 20 is divisible by 4, but can you say that 4 is a prime factor of 20? Note that 4 is a factor of 20, but 4 is not a prime number. That's why every factor cannot be the prime factor of a number. Four is a factor, but it is not a prime number. The prime factors of 20 are 2 and 5. Prime factor is a factor of a number, but is always a prime number. HCF is never 0. While writing the prime factorization of 4, we have 4 is equal to 2 into 2. Whereas writing the prime factorization of 9, we have 3 into 3. Now, when we are finding the HCF of 4 and 9, we forget that 1 is also the common factor between 4 and 9. Let us see the HCF of 4 and 9. 4 can be factorized as 2 into 2. 9 can be factorized as 3 and 3. So, is it okay to write HCF of 4 and 9 as 0? No. The HCF of 4 and 9 is 1. If there is no common factor, then always remember that the HCF is 1, not 0. Now, HCF is a product of common factors. We should take care while we are finding the HCF. Consider the numbers 4 and 12. We can prime factorize the number 4 as 2 into 2 and 12 as 2 into 2 into 3. While finding HCF, we should take care that if we see 2 as a common factor of for both the numbers, can we write the HCF of 4 and 12 as 2? No. HCF is not the common factor, but it is a product of all the common factors. We can see that 2 is repeated twice. So we have 2 into 2 as the HCF of 4 and 12. That's why HCF of 4 and 12 is 2 into 2, which is 4. Now, LCM by prime factorization method. Care should be taken while finding LCM by the prime factorization method too. If we consider the numbers for 70 and 84, the prime factorization of 70 is 2 into 5 into 7. Prime factorization of 84 is 2 into 2 into 3 into 7. What is the LCM of 70 and 84? Note that the LCM of two numbers is a product of prime factors that occurs the maximum number of times in any of the numbers. Note that 2 occurs a maximum number of 2 times in the prime factorization of 84. Hence, LCM is, we take common 2, then we multiply the common number 7, and then we have the uncommon factors, that is 2, 3 and 5, which are remaining here, and in this way we get the product as 420. So the LCM is not 210, the LCM is 420. Let us see some of the exam tips. You have to practice a variety of questions from NCERT textbooks, exemplar, other textbooks, and from previous year's question papers. You should note down all the definitions and properties separately to glance at before going to attend the test. Especially, you have to understand and learn the divisibility rules table. You should avoid calculation mistakes, especially in the case of finding HCF and LCM of two numbers. Be thorough with divisibility rules. This helps you to factorize the numbers easily while finding LCM and HCF by prime factorization. Also, check if you have answered all the questions and all parts of the questions. I hope this session was helpful, and if you want to quickly revise the concepts, practice some extra sums, and also take a quick test, Counting Well Exam Prep Kit is here. Counting Well Exam Prep Kit lets you quickly glance through the major concepts of your chapter. You can also glance through solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks, common errors that you make, etc. Over 75,000 students trust Counting Well for their maths learning. Even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well and learn more tricks and tips and avoid common mistakes. We will be revising the chapter Data Handling and Algebra from Class 6 in our next live session, that is on next Friday, that is 4th February at 6:30 p.m. Well, see you in the next session. Until then, keep learning, keep growing. Thank you.